Okay, let's start. In the previous video, we already explained how to handle overfitting problem. It is a very common in your neural network training process. That means if you have good result on your training data, but then for the unseen, the test data which is not seen by the model, the neural network performs very bad. That's called overfitting problem. Then we discussed the PyTorch implementation for early step for regularization. And then finally we talk about dropout. Dropout is a very useful techniques to overcome the overfitting problem, especially for neural network. Okay, regularization has been used in many other machine learning like linear regression, but dropout only applies to neural network. Okay, the idea of dropout is every time for each epoch we just drop out some neurons. We have some percent to drop out for the input, for this layer, for each layer. So the idea is if we drop out the neural network, then the input will become thinner. Okay. And after training each epoch, we use a different thinner structure of neural network to train. And during test, we use the whole neural network. But then we have to apply 1 minus p probability to the ratio to all the weight. Okay, let's take a look at the PyTorch implementation of this dropout. Okay, open GitHub, and then you select the dropout. I leave the original one and continue to run. Delete all the sessions. Rerun again. Okay, initialize. Now it's connected. Import PyTorch. Check for GPU. Generate data. Take a look at my data. Now I want to build my neural network with dropout. So here it means we want to build a neural network with some dropout. So because our input has only one node, so it won't make sense to drop out. Okay, if your input have say for the 20 or 200 features, as in the real world case, then you may apply dropout. But in our case, our input layer contain only one node, so I don't apply any dropout for my input. But then I apply a probability 0.5 dropout to this 100 nodes in the first layers, and then I apply another 20% dropout to the 50 node in the second layer. Okay, so now I define and then take a look at my parameters. So now I have 5,000, but as you know, if I apply the dropout during training each epoch, PyTorch will automatically, based on the probability I give, to select some nodes to drop out. So every time I train using a different thinner structure of neural network to train. Same loss function and same optimizer. So I just train my neural network each epoch. Okay, for each epoch, PyTorch will drop out some nodes based on my the probability I gave. So each epoch I train a different structure, a thinner different structure of my neural network. And take a look at the loss function. Now, during test, I use the whole structure, but then I have to apply the weight by 1 minus p%. For example, in my setting here, I use 0.5%. So here for the weight I get, I have to multiply by 1 minus 0.5. Here I use a dropout 0.2. Then here I have to apply a weight 1 minus 0.2. To do this, PyTorch will automatically do this for us. We just need to tell PyTorch, now my model will go to evaluation mode. So in that case, PyTorch knows to automatically add the weight during. Okay, so now PyTorch knows I am in an evaluation mode, not in a training. So now I want to test my performance on the training data. And here, test my performance on the, let me see, 190. Oh, in this case, unfortunately, it's not good. I don't know why. When I try to demo this online, its performance is not good. Okay, but anyway, I just show you how to do, what's the concept of dropout and how to do this using PyTorch. So you might practice. Also, you might practice using your cubic or quadratic training data. Okay, and then in the Hongyi's slides, he explained why dropout will make neural net performs better. One reason, one intuitive reason is since we use less number of parameters, so all the remaining nodes knows, oh, I have to work harder, work better in order to make the neural network performs better. So each time we randomly drop out some nodes, the remaining nodes will become stronger. Then combinedly, the whole neural network will perform better. And then why we have to multiply the weight by 1 minus p% during 1 minus p%. Okay, during the test, Hongyi also explained this. Okay, intuitively during training, okay, we use only a part of the node. So during test, we use the whole node. So intuitively, we have to multiply some ratio. Okay, but for details, you might take a look at Hongyi's the video. Actually, let me see. More pages. Okay, and another way to take a look at why dropout makes a neural network perform better, we can from ensemble perspective. Just like the neural network, every time we sample a subset of data. Of course, in this case, we did not sample a subset of data because our data has only one. Okay, but if your data has multiple features, every time we subset up and train using a different structure of neural network. So the ideal, you can see the similarity. This idea is very similar to the ensemble approach we use in random forest. Okay, that's the idea. For more details, you might take a look at the Hongyi's videos. Okay, so finally, let's talk about the error of machine learning models. Okay, because just as you see, the machine learning models, we train a neural network to learn from a limited number of data. If you have any statistic, ideal, you know, okay, we will have the prediction accuracy, we will have bias. and the variance. This is from the Hongyi's slides. As you can see, when your model become complicated, then the prediction error will have larger variance. Okay, see, linear model and cubic model, and if we use the polynomial equation try to fit, then the variance is huge. So simpler model has smaller variance, but the bias may be large, means because the model is simpler, it cannot learn the exact answer. Complicated model, overall the bias is small, means it can predict the true answer, but the variance is large. So that's why we will get the overfitting problem. Okay, here I provide PyTorch code to demonstrate. So for details about the machine learning model, the bias and the variance, you can take a look at the Hongyi's video. Okay, so here, open. Now if you go to 1.4, 2.4 variance. Wrong. Continue. Okay, build a neural network. And get the name. Okay, now we save the initial weight and the bias of this neural network. So we torch save. This my net is my model. State dictionary means I want to save the weight, not the whole structure. Okay, so I save my initial weight. Take a look at so this model, I create a model with 30,000 parameters. Define the loss function and the optimizer. Then I generate 40 data. Okay, so I generate basically a linear model using a very complicated model. So you can expect I will have larger variance of my model. But the bias is because I can pretty much learn very well, but model prediction will have larger. So now during training, every time I just randomly select 80% of my data for training and 20% for test. Okay, and to be even, every time, every epoch, I load the initial weight. Okay, so I just train this model 300 times. Each time I train 500 epochs. Each time I using a different set of training and randomly pick up 80% training, 20% test data from my model, and I use the same initial weight. And every time I train 500 epochs, and then I want to record the test, the loss function of my test data. Okay, now let's start. Okay, this may take a while because, okay, I train for 300 times. Every time I train 500 epochs, and then I collect the loss function. And finally, I want to plot. If the model learns very well, then the model should have smaller variance. Means the box plot, you will see the variance is small. Okay, and the loss is small. Okay, so let's train this model for a while. I print out every 20. Okay, so here I'm going to wait. Let me. Okay, I have already finished the training process. Let's take a look at the box plot of this 300. As you can see, the average of the training loss is still not good, and the variance is large. So that means if I use this training process to train this model, I get large variance, and the BIOS is not good at all. Okay, I just want you to, to run my code and try to practice on the quadratic or cubic training data. Okay, and here is the, so when your model, this is a slide from Li Hongyi, for the overfitting case, which we usually have, this is error we observe, when the model become complicated, we will have bad performance on the test data, and for underfitting case, the error is due to the BIOS. For overfitting, the error is from the variance. And then, of course, we can increase the data to reduce the variance. And finally, Li Hongyi just made that's the common approach we took in neural network training. First, we will split our data to training and the test. And then for the training data, we split again to training and validation. If the model performs good on the training data, then we test it. The model has to perform both good on the training and the validation. And then finally, we test it on the test data. So with this, I finished the introduction of the deep learning and the PyTorch implementation for regression.